is a superconductor? Or for that matter, what's a regular conductor? Conductors are materials that allow electricity to flow through, like copper. Most of the wiring in your house is copper. But copper has a problem when electricity flows through it. Electrons bump around, wasting energy as heat. That's called resistance. A superconductor has no resistance, zero. So the current flows through it without wasting any energy.
This is copper wire that we have in our house normally.
And these are normal light bulbs. But Cooch is going to run much less power through them than normal.
Okay, so we're at 12 volts.
That's only 1/10 of the voltage we use in our homes.
It's not very bright.
That's what we get from the copper wire. Watch what happens when we run the same 12 volts through the superconductor. From a dull glow to full throttle. So you're getting a lot more out of your electricity.
Getting a lot more out of it.
You're wasting a lot less.
Yes.
Scaled up, that wasted energy just in the United States grid alone could power 14 New York cities every year. But that's just the start. Scientists have been working on harnessing the properties of superconductivity for much more exotic applications.
Now I put the superconductor.
Here at the University of Paris, Professor Alain Secuto showed me something extraordinary that happens when a really cold superconductor meets an ordinary magnet.
Oh! And there is levitation now, you know?
And this little puck is just the tip of the iceberg.
Oh, come on! Let's go.
Back to the future!
I'm actually surfing above the ground.
I'm flying!
And it's more than just fun and games. Engineers in Japan are already scaling it up to create the world's first superconductor maglev passenger train. It flies above its tracks at speeds up to 311 miles per hour. And it's cold that makes it happen. So, what's the trick? You might think that the superconductor is acting just like a magnet.
This is now a magnet?
But you'd be wrong.
It's not like a magnet because here you have both repulsion and attraction.
So these two disks have repulsion and attraction?
Both.
And that's not how a proper magnet behaves. It can't do both at the same time. The superconductor can, because it warps the magnetic field of the magnet to a point where it attracts and repels at the same time.
It's both directions. It's
both
locked.
directions.
But how is this possible? How do superconductors actually work?
Look at that.
The crazy part is, scientists don't really know. It has something to do with that Q word.